Educator.com. In previous lessons, we learned how to solve quadratic equations by graphing. In today's lesson, we're going to learn another technique for solving these equations. And this technique is called completing the square. This technique applies to perfect square trinomials and trinomials that we can actually turn into perfect squares. So if an equation has a perfect square trinomial on one side of the equation, you solve by taking the square root of both sides. Let me go ahead and show you an example. So remember the general form ax squared plus bx plus c equals 0. That is the standard form for a quadratic equation. And you could have a trinomial such as x squared plus 6x plus 9 equals 0. And on this left side, I do have a perfect square. This actually factors out to x plus 3 squared equals 0. Okay, now let's look at this first situation where we have this x plus 3 squared equals to 0. If I take the square root of that, I'm going to get x plus 3 equals plus or minus the square root of this other side. Recall that I'm using the square root property. And the square root property says that if I have a squared equals b, I can solve for a by taking the positive, find the square root of b, and its positive value of that, find the square root of b, and then negative, whatever that result is. For example, if a squared equals 9, the square root of a equals plus or minus the square root of 9, so a equals plus or minus 3. Because both 3 squared and negative 3 squared are equal to 9. So again, I'm going to take the square root of both sides. Now in this case, square root of 0 is 0. So it's going to be plus or minus 0, which is just 0. I don't actually have two different results. When I solve for x, I get x equals negative 3. And I demonstrated this to show you something we discussed last time, the idea that there can be actually one double root, which will give you two identical solutions. And that's what happened here. There's two solutions, plus or minus 0, but since plus 0 is the same as minus 0, I just come up with one unique number, x equals negative 3. Usually, that doesn't happen all the time. A lot of times you get two distinct solutions. Let's look at a slightly different equation. This time let's look at x squared plus 6x plus 9, and let's have that equal 4. Again, it's going to factor out to x plus 3 squared, this time equal to 4. Use the square root property and take the square root of both sides. And I'm going to take plus and minus the square root of 4. So x plus 3 is going to equal plus or minus 2. So I'm going to get x plus 3 equals 2, and x plus 3 equals negative 2. I can solve each. So x equals 2 minus 3, which equals negative 1. X equals negative 2 minus 3, which equals negative 5. So my solutions for x are both of these values, negative 1 and negative 5. So here I had two distinct solutions. So we're going to use the square root property to solve equations that have perfect square trinomials on one side. One important quality to know is that you can recognize perfect square trinomials because their constant term is equal to b divided by 2 squared, or b squared over 4. And if you look at a perfect trinomial square like this, perfect square trinomial, you'll see that here b equals 6. And if I take b squared and divide it by 4, I get 36 divided by 4, and it is 9. So here b equaled 6 and c equal 9. And since my constant fits this formula, that tells me that I am working with a perfect square trinomial, and that's important to know. Sometimes we aren't lucky enough to have a perfect square trinomial. In those cases, what we do is we complete the square. We make it into a perfect square trinomial. So if I have something such as an expression like x squared plus bx, I need to add another term to turn it into a trinomial that is a perfect square. Now, you notice what we're adding is b squared over 4, which is an expression I just mentioned. And I said that in a perfect square trinomial, c equals b squared over 4. So if you have your standard form and this is a perfect square trinomial, c is going to fit with this formula. So what I'm going to do is I'm going to take what I have and add the correct c term, b squared over 4, to give me a perfect square trinomial. And then I can go about factoring and using the square root property to solve it. For example, let's say I have an expression such as x squared minus 10x. What I need to do is find b squared over 4 so that I can turn this into perfect square trinomial. So I want x squared minus 10x plus b squared over 4. All right, I know that I have b equals negative 10. So I'm going to go ahead and find what this would come out to. And b squared would be negative 10 squared over 4. So negative 10 times negative 10, that's going to be 100 divided by 4. Which is 25. This is a perfect square trinomial. This is going to factor out to what it's showing right here. X plus b over 2 and all of that squared. So I have x plus, although here I have a negative, so it's actually going to be minus b over 2 squared. Okay, first let me go ahead and take the square root. That's x, and the square root of this, because this is still b squared, and that's 5. Okay, so this is completing the square and then finding figuring out what your perfect square trinomial is, and it turns out that this would be x minus 5 squared. And this is going to go ahead and allow me to solve the equation. Okay. So just to review this section again, what you're going to have is x plus b squared. Here, b is 10. So if b is 10, you're going to end up with x plus 10 over 2 squared. Is going to be the general form, but because I have a negative, I need to make this a negative. And that's going to give me x minus 5 squared, which is this. So if I didn't just recognize that this is x minus 10x plus 25, if I just didn't remember or want to go work through the whole thing to figure out this is x minus 5 squared, I can use this formula that shows that this factors into x plus b over 2, all of that squared. Okay, now, so we can use these techniques in order to solve equations. If you have an equation such as this, you first complete the square, as we discussed, then take the square root of both sides. And that's using the square root property. For example, if you have x squared plus 6x equals negative 8. You can complete the square and then go ahead and take the square root of both sides to solve for your solutions for x. Recall that in order to complete the square, you're going to have a c term that equals b squared over 4. So, what I want to do is I want all my variables over on this left side, and I already have that. And I'm going to get x squared plus 6x plus b squared over 4 equals negative 8 plus b squared over 4. You need to add this to both sides. If you don't, you won't have a balanced equation. And it's easy to forget that you need to also add this term to the right side. You are completing the square, but you need to balance the equation. When you add something to one side, you need to add it to the other. Okay, so here, b equals 6. So this is going to give me 6 squared divided by 4 equals negative 8 plus 6 squared divided by 4. And that works out to 36 divided by 4. Which is 9. Okay, what I have on the left now is a perfect square trinomial, and on the right I have 1. With the perfect square trinomial, you can then go ahead and factor that out. And remember that this is equal to this. And I said that b is 6, so I could have just said 6 divided by 2, x plus 3, all of that squared. So I happen to know what this factored out to, but if I didn't, I could find it by letting b equal 6 and dividing by 2. Equals 1. I'm going to take the square root of both sides, and that's going to equal plus or minus the square root of 1. So x plus 3 equals plus or minus 1. X plus 3 equals 1, plus 1. X plus 3 equals negative 1. So I solve this out, and I get x equals, if I take 1 minus 3, I'll get negative 2. Negative 1 minus 3 equals negative 4. So I have two solutions, and they are negative 2, negative 4. Those are my solutions. Now, this took a few steps, but it is worth it because it's an easy way to solve. So, if you have an expression such as this, get all the variables on the left, complete the square by adding b squared over 4 to both sides, then you have that perfect square trinomial. You just need to factor according to this formula, and then take the square root of both sides. Sometimes the leading coefficient is not 1, and that does make things a little bit more complicated. You have one extra step. And we've talked so far, you'll notice the examples that I've showed you, the leading coefficient was 1. We just had x squared plus bx plus c, and really we had an a, but a always equaled 1 before. When a is something other than 1, we need to get it so that a is 1. And you're going to do that by dividing each term by a. And then you proceed as we discussed, completing the square, factoring, and then taking the square root of both sides. For example, if you have 2x squared minus 12x plus 4 equals 0, the first thing you want to do is divide everything by a. So here, a equals 2. Since this is something other than 1, I need to eliminate it. I need to turn it into 1. So I'm going to divide everything by 2. That's going to give me x squared minus 6x plus 2 equals 0. Then I'm going to go ahead and complete the square. I want all my variables on the left, everything else on the right, and then I'm going to proceed just as we discussed previously. So remember, there's an extra step here. I need to divide everything by a to turn this into 1. then complete the square, and then use the square root property to solve for x. All right, let's apply these concepts to the examples. In my first example, I have x squared minus 6x plus 36. And 36, the square root of that is 6, so this might be a perfect square. And the quickest way to check for that is to look. Does c equal b squared over 4 in this situation? Well, c right here, we have to figure this out. So c equals b, so b is negative 6 squared divided by 4. So c equals 36 divided by 4. Okay, so I find out that this equals 9. But actually, that is not the case. This does not equal 9. So I know that I don't have a perfect square trinomial. If I did, when I took b squared divided by 4, and here it's negative 6 divided by 4, which is 36 divided by 4 would be 9, that should give me my term for c, because it's ax squared plus bx plus c equals d. This is a way to check and see if I've already got a perfect square trinomial. I don't. What I'm going to do is make it a perfect square trinomial by completing the square. First step, put all the variables on the left. I have a constant on the left. I need to move that to the right by subtracting both sides by 36. These cancel out. I get 11 minus 36. That is negative 25. Now, complete the square. You complete the square by adding b squared over 4 to both sides. What's crucial is that you add that to both sides. I already figured out b squared over 4 when I was checking to see if I had a perfect square trinomial. So that makes it easy. Just go ahead and substitute in 9 for b squared over 4. And this gives me x squared minus 6x plus 9 equals negative 25 plus 9, which is negative 16. This factors to x minus 3. Remember that. You can just figure this out because it's b divided by 2, which would give me a negative 3. So I have x minus 3 squared equals negative 16. Now you need to use the take the square root of both sides using the square root property to get x minus 3 equals the square root of negative 16. And here's where there's a problem, because this equals plus or minus the square root of negative 16. But the problem is we can't take a square root of a negative number and get a real number. You can get something, but it is not a real number. So what we're talking about is that there are no real solutions. So we're just going to say there is no solution for what we're talking about in this course. I'm not going to go any farther. I'm just going to say that I can't take a square root of a negative number, so there is no solution, no real solution. Now, this took a bunch of steps. The first thing I did was to verify that this was not a perfect square trinomial, because c did not equal b squared over 4. C did not equal 9. If this was a perfect square trinomial, c would have equaled 9. I have to turn it into a perfect square trinomial. In order to do that, I want to get all the constants on the, so get variables on the left and the constants on the right. Then complete the square by adding b squared over 4 to both sides. Once you have a perfect square trinomial, factor and then use the square root property. Take the square root of both sides. And if it turned out that I had an a that was something other than 1, a leading coefficient other than 1, I would have had an extra step here because I would have had to divide everything by a. Okay, now we're being asked to find the value of c to complete the square here. So we have z squared minus 7z plus c. Well, recall that c equals b squared over 4 for a perfect square trinomial. Here, a equals 1, so I don't have to divide by a. I've already got 1. And b equals negative 7. So to complete the square, I'm going to have z squared minus 7z plus c, but I'm going to put in, instead, b squared over 4. Therefore, z squared minus 7z plus b squared over 4, and that's negative 7 squared over 4. So z squared minus 7z plus 49 over 4. Okay, now, remember that to factor this out, what you're going to get is x plus b over 2 squared. X plus b over 2 squared to factor a perfect square trinomial. In this case, our variable is actually a z, so I'm going to write it as z, plus b, which is negative 7, over 2 squared. So this is going to come out to z minus 7/2 squared. When b is an odd number, you end up with a fraction here when you factor it. So it's not as easy to work with, but that's because when b is an odd number and you go to factor it in this form, you have to divide by 2. So anytime b is an odd number, you're going to end up with a fraction. If this were an even number, such as 8, I would end up with a 4 here, an even number. Okay. All right, in this next problem, we're asked to complete the square. So I look at this and I see that my a is equal to 1, so I don't have to do that extra step and divide everything by a. Then I want to look at what I have, and they've asked me to complete the square, so I know that I don't already have a perfect square trinomial, but I could always verify that by seeing if c equaled b squared over 4. First step, put the variables on the left, constants on the right. So let's add a 7 to both sides to move that 7 over to the right. To get y squared minus 4y equals 17. Now I need to complete the square. To complete the square, you're going to add b squared over 4 to both sides. Okay, y squared minus 4y plus b squared over 4 equals 17 plus b squared over 4. Looking at what I have negative 4 for b. Okay. So this is negative 4 times negative 4 is 16 over 4. This is y squared minus 4y plus 4 equals 17 plus 4. So that comes out to y squared minus 4y plus 4 equals 21. Factor this into y minus 4 divided by 2 squared equals 21. Now use the square root property. Take the square root of both sides. And this is going to give me y equals 2 plus or minus the square root of 21. Okay, in the fourth example, again, I'm asked to solve by completing the square, but this time I have a leading coefficient of 2. So I'm going to divide everything by 2. First, let's go ahead and put the constants on the right, the variables on the left, so that we have it in the correct form to complete the square. And that's going to give me 2x squared plus 16x, subtract 8 from both sides, equals 10. Next, divide by 2. So I'm just going to go ahead and divide everything by 2. And that's going to give me x squared plus 8x equals 5. Okay, now I can go ahead and complete the square by adding b squared over 4 to both sides. And in this case, b equals 8. So that's going to give me 8 squared over 4. Eight squared is 64. Okay, go ahead and finish out up here. So 64 divided by 4 is 16. Simplify the right side, and that gives me 21. This factors out to x plus 4 squared, because b divided by 2 is 4, equals 21. Take the square root of both sides to get x plus 4 equals plus or minus the square root of 21. Subtract 4 to get negative 4 plus or minus the square root of 21. So this was a little bit complicated. We put all the constants on the right, variables on the left, divided by 2. And then once we got that, we had x squared plus 8x equals 5. Complete the square by adding b squared over 4, which turned out to be 16. Add 16 to both sides. I got my perfect square trinomial, which factored to x plus 4 squared equals 21. Take the square root of both sides. X plus 4 equals plus or minus the square root of 21. Isolate the x by subtracting 4 to end up with my two solutions for x. So x equals negative 4 plus the square root of 21, and x equals negative 4 minus the square root of 21. That concludes this lesson on Educator.com.